Chapter 13. The Unified Wallet Manager. As previously identified, the single greatest UX challenge is managing player interactions across two separate blockchain ecosystems, Xrpl and Songbird EVM. The solution is a client-side architectural pattern, the Unified Wallet Manager. This will be a singleton class within the Unity client, acting as the central point of contact for all blockchain-related interactions. Design and implementation. The Unified Wallet Manager will be responsible for initiating connections, tracking state, and routing signing requests to the appropriate wallet. It will integrate multiple SDKs and libraries to achieve this. Xrpl connection. It will use the XUMM SDK to generate and manage sign requests for the Xrpl. EVM connection. It will use a library like ethers.js in conjunction with a wallet connection manager like Wallet Connect, or a dedicated SDK from a provider like ThirdWeb or Dynamic. This allows for connection to a wide range of EVM wallets, including MetaMask, Coinbase Wallet, and others. 40. The onboarding and interaction flow. The user experience will be orchestrated by the manager as follows. Initial connection. On the game's main menu, a single Connect button is presented. Tapping this button opens a custom UI modal. This modal will have two distinct sections: Connect Xrpl Wallet, XUMM, and Connect EVM Wallet, MetaMask, etc. The user is guided to connect both wallets sequentially. The UI should provide clear feedback, showing a connected status with the user's address for each wallet once successful. The manager will securely store the public addresses and maintain the connection state for both. Context-aware transaction. Routing. All in-game buttons that trigger on-chain actions will call methods on the Unified Wallet Manager, not directly on a specific wallet SDK. Example 1. Entering a tournament. The Enter Tournament button in the UI calls Unified Wallet Manager. Enter Tournament ID. The manager's internal logic knows that this requires a transaction on the Songbird network to pay the entry fee to the match escrow contract. It therefore constructs the appropriate transaction and uses the connected EVM provider to prompt the user for a signature, e.g., a MetaMask pop-up appears. 41 Example 2. Claiming a prize. After winning, the Claim Prize button calls Unified Wallet Manager, Claim Prize. The manager knows that receiving the prize on the Xrpl first requires a trust set transaction. It uses the XUMM SDK to generate a trust set payload and presents a QR code or push notification prompt for the user to approve in their XUMM app. This architecture ensures the user is always presented with the correct action in the correct wallet, creating a single, cohesive experience from what are technically two separate, parallel systems. Chapter 14. Designing the Web3 in-game HUD. The heads-up display, HUD, during gameplay, and the surrounding menu screens must integrate Web3 elements in a way that is informative but not intrusive. The design should prioritize clarity and follow established UX best practices for decentralized applications. 71 Information, hierarchy, and key UI elements. Balance display. The player's balances of MB589 and MG589 tokens should be displayed clearly but unobtrusively, perhaps in the main menu or player profile screen, but not cluttering the in-fight HUD. Tournament bracket view. A dedicated tournament screen is essential. This screen will visualize the entire tournament bracket, updating in real time as matches are completed. The player's own position in the bracket should be clearly highlighted. This screen will fetch its data from an indexing service that reads events from the Tournament Manager contract on Songbird. Transaction notifications. On-chain actions are not instantaneous. The UI must provide clear, non-technical feedback on the status of transactions. Instead of showing a transaction hash, the UI should use friendly messages like, confirming your tournament entry on the Songbird network. Entry confirmed. Your match will begin shortly. Sending your prize to your Xrpl wallet. Success. 1000 MB589 has been delivered to your wallet. NFT character selection. The character select screen will be dynamically populated with the Meme Warrior NFTs that the game detects in the player's connected Xrpl wallet. This provides a direct, tangible link between on-chain ownership and in-game utility. Web3 UX best practices. Progressive disclosure. Do not overwhelm new players with complex Web3 concepts. The initial experience should focus on the game. Advanced features, like viewing transaction details on a block explorer or managing collateral as an F-Assets agent, should be available but tucked away in advanced settings menus. 73. Avoid jargon. Use simple, understandable language. Replace gas fees with network fee, signing a transaction with approve action, and minting with creating. 72. Clarity and security. The UI must be explicit about what the user is being asked to approve in their wallet. Before triggering a sign request, the game should display a summary such as, "You are about to approve spending 50s MB 589 to enter the tournament." This will be held in a secure contract until the tournament ends. This builds trust and helps prevent users from signing malicious transactions. 73. Part 7. Operations, Security, and Implementation Roadmap. The final phase of the project involves ensuring the system's security, planning for its operational needs, and defining a structured, phased roadmap for development and launch. This strategic approach is designed to manage complexity, mitigate risk, and maximize the probability of a successful deployment. Chapter 15. A 360-degree security audit plan. A comprehensive security audit, conducted by a reputable third-party firm, is an absolute requirement before any mainnet launch. The audit must be holistic, covering every component of the architecture, as a vulnerability in any single part could compromise the entire system. Smart contract audit. This is the most conventional part of the audit. The auditors will review the solidity code for the tournament manager, match escrow, and dispute resolution contracts. They will search for common vulnerabilities such as re-entrancy, integer overflows, underflows, access control issues, and flawed business logic. The use of established libraries like OpenZeppelin will provide a strong foundation, but the custom logic for bracket management and prize distribution must be rigorously tested. 44. Bridge security audit. The Facets bridge represents the largest concentration of value and is therefore the most attractive target for attackers. The audit must scrutinize the interaction points between the game's backend and the F-Assets agent infrastructure. It should analyze the potential for cross-chain replay attacks, where a transaction on one chain is maliciously resubmitted on another, and verify the security of the agent's collateralization and liquidation mechanisms. The reliability and security of the Flare data connector's attestation process is also a key area of focus. Authoritative server audit. The server's code must be audited for security vulnerabilities that could lead to a compromise. If an attacker gains control of the server's private key, they could submit false match outcomes to the smart contracts. The audit should cover network security, API endpoint protection, and the secure storage of the server's signing key. Client security audit. Even with an authoritative server, the game client needs to be audited. The focus here is on preventing exploits that could degrade the user experience, leak player data, or be used for denial of service attacks against the game server. Chapter 16. Phased Implementation Roadmap. A common failure pattern for ambitious Web3 games is to spend immense resources building complex on-chain infrastructure for a game that ultimately is not fun to play. This roadmap is specifically designed to mitigate that risk by front-loading gameplay development and layering in the blockchain components incrementally. This approach allows for rapid iteration on the core game loop, while systematically de-risking the technical complexity of the dual-chain architecture. Table 4. Implementation Roadmap and AMP. Milestones. Component Phase 1. Core off-chain MVP, 8 to 12 weeks. Phase 2. Single-chain integration, 12 to 20 weeks. Phase 3. Dual-chain integration, 20-32 weeks. Phase 4. Security audits and AMP. Launch game client, Unity. Build core fighting mechanics. Implement 1v1 local multiplayer. Create 2 playable characters and 1 arena. Integrate Xrpl wallet connection, Xamarin SDK. Build NFT character selection screen. Display token balances. Integrate EVM wallet connection, Wallet Connect Ethers.js. Build unified wallet manager. Develop tournament bracket UI. Implement final UI/UX polish based on beta feedback. Integrate final art assets. Authoritative game server. Develop authoritative server for 1v1 matches. Implement rollback netcode. Store match results in a traditional database. Connect server to Xrpl to verify NFT ownership for character selection. Develop manual prize payout script for testnet tokens. Integrate server with Songbird smart contracts. Implement automated, signed match outcome reporting. Harden server security based on audit findings. Deploy to scalable multi-region infrastructure, e.g. AWS, GCP. Xrpl integration and issue MB589, MG589 tokens and character NFTs on Xrpl testnet. Build backend services to query wallet assets. NA issue all assets on Xrpl mainnet. Establish initial liquidity on the Xrpl DEX. Songbird contracts. NA deploy tournament manager and match escrow contracts to Songbird testnet. Implement registration and bracket logic. Deploy audited contracts to Songbird mainnet. Set up administrative multi-sig wallet. Bridge integration and NA setup, or partner with an F-Assets agent on testnet. Integrate backend with F-Assets for wrapping, unwrapping entry fees and prizes. Transition to mainnet facets protocol. Ensure agent is fully collateralized and operational. Primary goal: prove the game is fun and playable. Prove the Xrpl asset layer and wallet UX are solid. Prove the end-to-end dual-chain architecture works. Launch a secure, polished, and fully functional game. This phased approach ensures that the most fundamental aspect, the quality of the game itself, is validated before the significant investment in complex blockchain integration is made. Each subsequent phase builds upon a proven foundation, systematically tackling technical risks and moving the project closer to a successful mainnet launch. Following the completion of Phase 3 and a successful security audit, the project can confidently proceed with a public beta, a bug bounty program, and ultimately, the full public launch of the game.